Hey, good morning, Math 7 people, and anybody else who watches this. This is about some proportional relationships in tables, or maybe not proportional relationships. Okay, so we're going to make tables today. So you have decided, this is day 4. We've decided, or this example is, you got a long distance race, very long distance. There are 2 teams. Team A walks at a constant rate of 2.5 miles per hour. Team B walks 4 miles the first hour and then 2 miles per hour after that. Can we create a table for this? All right. Well, I have purple. I'm going to do B in purple. So it says they walk 4 miles the first hour. So I already put the numbers in for the hours in the table. So these guys walked 4 miles the first hour. It's pretty fast. And then after that, they got tired, so they could only walk 2 miles per hour after that. So over here, the second hour, they're going to walk 2 miles more than they did afterwards. So this is going to end up being 6, because that's 4 plus 2. And then the next hour, they walk 2 more. So 6 plus 2 would be 8. The next hour, they walk 2 more, so that's going to be 10 and 12 and 14. So after 6 hours, they've walked 14 miles. That's pretty good. Okay, so now Team A. Team A, they walk 2.5 miles per hour. So after the first hour, they've walked 2.5 miles. And then the next hour, they walk another 2.5. So 2.5 plus 2.5 makes 5. And then they walk another 2.5. So 5 plus 2.5 is 7.5. And then they do 7.5 plus 2.5 makes 10. And I did this ahead of time. Don't be amazed. And then 10 plus 2.5. This one's easy. 12.5. And then 12.5 plus 2.5 makes 15. So here are my numbers. Notice that different people are in the lead, right? So at the very first part of the race, look, Team B, after 2 hours, Team B walked 6 miles. Team A only walked 2 miles. Even after 3 hours, Team B is ahead of Team A. But notice what happens at 4 hours. 4 hours, they've both walked the same amount, haven't they? They both walked 10 miles after 4 hours. And then, look what happens. Now, after 5 hours, Team A is ahead of Team B. And so on. So they cross in the middle, don't they? Yeah. So we're going to make some graphs. I made the graph already because I don't know why I put the graph paper there, but I did. And so I want you to notice these 2 graphs. Okay, I did the best I could this morning. It was kind of early. Okay, notice this one right here. Notice how it goes through this 0, 0 point and how this graph does not. Okay, that's something later we'll talk about a lot. Which of these is proportional relationships? Right, A is proportional relationship because every hour you change the same amount. You did at Team B, but notice the first hour you walked 4. So this first one, you did 4 in an hour. The next one was 6 over 2. That's 3, right? They're not the same. 10 divided by 4, isn't that 2.5? So these are not the same ratio. They're not the same unit rate. So this is not proportional. But if I go over here and I do the same thing, I do 2.5 divided by 1. Well, then I do 5 divided by 2. Well, that is 2.5, right? And I do 10 divided by 4, and that was 2.5. I do 15 divided by 6. My bad. That's going to be 2.5 also. But we made the table that way because it said every hour we walk 2.5 miles. So this one is proportional. The one on the other side is not proportional. And then look at the graphs again. Notice they both have straight lines, don't they? But again, notice that the proportional one goes through the origin, the 0, 0, and the non-proportional one does not. Okay, so for which team is distance proportional to time? We already said that up at top, team A, because all the ratios are equal. Okay, B, explain how you know distance for the other team is not proportional to time. Well, we can say all the ratios are not equal. At what distance would it be better to be on team B? Team B, we want distance to be better, so we want to win. So team B goes farther where? Remember we talked about that at the beginning. So notice up to 3 hours, team B is ahead every time of team A. So at what distance? Looks like anything less than 10, right? Any distance less than 10 miles, team B is faster. See how I'm writing all these words? All right, if members on a team walked for 10 hours, how far would each member walk on each team? Well, A is easy to figure out because remember they're 2.5 miles per hour. And if I go for 10 hours, I can just do 2.5 times 10, and that gets me 25 miles. It's not so easy with B, right? B, I might want to come back up here and just try to figure it out. 7 would be 16, 8 would be 18, 10 would be 20, right? So it looks like after 10 hours, for 10 hours, this is only 20 miles for team B. Will there be a winning team no matter what the length? And you look back and you go, oh no, there's not. Look right here in the middle. I'm going to change colors because it's kind of hard to see through that. Look right here. If the race was 10 miles, each team would have finished at the same time. So that's what that's talking about. So 10 miles, both teams take 4 hours. If the race is 12 miles long, which team would you choose to be on? Okay, so 12 miles. Notice 12 miles. Team B did it in 5 hours. Team A did it in less than 5 hours, right? Because in 5 hours, they've already gone 12.5. So Team A is the better one for 12 miles. So Team A is faster for 12 miles. How much sooner would you finish on that team compared to the other team? Interesting, right? So Team B to go 12 miles took, how long? I have to go back up and look. 12 miles took 5 hours. How long does Team A take? Well, I don't know exactly yet. I know 12.5 took 5 hours, but that's not the question. So this one I'm going to do my 12 miles divided by my rate, which was 2.5, and I didn't do this ahead of time. So let me get my calculator out and say 12 divided by 2.5, and I get 4.8 hours. So Team A took 4.8. How much sooner? That means I'm going to subtract 5 hours minus 4.8 hours, which is 0.2 hours, right? If I want to know how many minutes that is, remember there are 60 minutes in an hour, so 0.2 times 60. 0.2 times 60 is 12 minutes.